Alright, here we go with iChem lesson 12 on covalent bonding. Really getting a lot better with those Lewis dot structures and what they mean for understanding the forces in our molecules. So we talked a little bit about the Lewis dot structures in the guided inquiry in class today, but let's just put a definition down. Electron dot diagrams that show how electrons are arranged in molecules. So in the guided inquiry we did all just dots representing all of the electrons. So we simplify them a little bit here now with, we know that they show only the valence electrons, but this diagram has dashes representing bonding pairs. So every line represents a pair of electrons. It limits, it reduces the amount of dots you have to draw. And then every non-paired electron, or lone pairs or non-bonding pairs, is drawn just as your dots. And then in the case of a polyatomic ion like this one, you'll have brackets and charge to signify the polyatomic ion. So we're going to just look at this structure and how it relates to things that we already know. You have one nitrogen here, and 1, 2, 3 oxygen, and a negative charge. This is your nitrate polyatomic ion. So we can look at a structure pretty easily and identify what it is. The harder part is drawing the structures itself. So the steps are a little bit different than the ones from our guided inquiry because now we're trying to do it in a much more efficient way. I wanted you to do it the way we worked on the past couple of days because I wanted you to see where those electrons, those shared electrons, come from. But now we're just going to learn how to draw these structures the most efficient way. So the first step is to total up the number of valence electrons. Then arrange the atoms within the molecule in such a way that the one with the least valence electrons goes in the middle, with the exception that hydrogen is always terminal, which means hydrogen is always on the outside. Then place in bonding pairs, the bond lines between the atoms. Check how many pairs remain. So how many have you used up with your bond lines and how many are left, and then distribute those electrons around the remaining atoms so that everybody who needs 8 has 8. If not, then we're going to learn how to draw in double and triple bonds. The exception here that you need to be careful of is hydrogen needs only 2. Pause it if you need to keep writing. These steps will show up on the next slides as well. Alright, so first thing we're going to do is total the valence electrons. So carbon has 4, plus there are 4 hydrogen, and each of them has 1. That is a total of 8 valence electrons. Then I'm going to arrange my atoms. Hydrogen is always terminal, so I'm going to put carbon in the middle with the hydrogens, the 4 hydrogens all around it. Then I'm going to draw in my bonding pairs. A bond here, 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 and here. And decide how many pairs remain. Remember, each of these represents a pair. So 2, 4, 6, 8. I've used 8 electrons. I have none left. No pairs remain. I have nothing left to distribute. Now I'm going to check, does each atom have 8 valence electrons that needs 8 valence electrons? Hydrogen each only need 2, so that line 2, 2, 2, and 2. Carbon needs 8. So 2, 4, 6, 8. That's satisfied. That's my Lewis dot structure. Okay. So now, the next one. To practice some of our naming concepts from class, this is nitrogen, trihydride, based on our conventional naming system. Unfortunately, sometimes it's not always followed and other things have different names. You might also hear this called ammonia, like ammonium, but not an ion, ammonia. Alright, so I'm totaling up my valence electrons. Nitrogen has 5 valence electrons. I have 3 hydrogens. Each of them has 1 valence electron. That's 8 total valence electrons. And I'm going to arrange the atoms, keeping in mind that hydrogen is always around the outside. So I'm going to put nitrogen in the middle and my 3 hydrogens around it. Then I'm going to draw in my bonds. Every set is paired. Then I'm going to see how many pairs remain. Count them up first. 2, 4, 6 total electrons in pairs. I have 2 more. I need to distribute those around so that everybody who needs 8 gets 8. Hydrogens only need 2, so I don't put any more around hydrogen. 2 more around this nitrogen. I'm done with my electrons. Now check to make sure everybody who needs 8 has 8. Hydrogens each need 2, so I'm done with that. Nitrogen has 2, 4, 6, 8, so I'm done with that. This is my Lewis dot structure for ammonia. Now I have bromine gas. I need to total up my valence electrons. I have 2 bromines. Each of them has 7 valence electrons. That's 14 total valence electrons. Arrange my atoms. There's only 2, so there's no middle. I'll just put them side by side. Then I'm going to put in my bonding pair, 1 bond between the 2 bromines. That represents 2, so I have 12 electrons left. How many pairs remain? 12 total electrons. That's distribute those 12 around. I get 2, 4, 6, 8, 10, 12. Always distributing in pairs. So that's all 12 electrons done. Now check to see everybody who needs 8 has 8. 2, 4, 6, 8. That bromine's good. 2, 4, 6, 8. That bromine's good. Notice how I'm counting this line for both of them. This is a shared pair, so it counts as 2 for this bromine, and it counts as 2 for that bromine. This is my Lewis dot structure. Alright, now we're going to get into somewhere we need to start worrying about that double bond, triple bond action. Alright, so oxygen gas. 2 oxygens. Each of them has 6 valence electrons. That is 12 total valence electrons. I only have 2, so I'm going to put them side by side. There's no need for anything in the middle right now. So an oxygen here and an oxygen here. I'm going to place the bond between the 2 atoms. That represents 2 electrons. I have 10 left to distribute. I'm going to go 2, 4, 6, 8, 10. Well, now, count them up. This oxygen has 2, 4, 6, 8 around it. That one's good. But this oxygen only has 2, 4, 6 around it. This one does not have enough. So they need to share more. These 2 pairs, these 2 electrons, need to be shared between the 2. So the structure actually has oxygens with 2 shared pairs, called a double bond, and each of them has 2 unbonded pairs. This is my structure of oxygen. Alright, now carbon dioxide. Total up my valence electrons. Carbon has 6. No, it doesn't want. Carbon has 4 valence electrons. I have 2 oxygens, and they each have 6. That's a total of 16 valence electrons. I'm going to arrange them so that the carbon is in the middle, we'll learn that the other molecules want to get as far away from each other as possible, so it's best to kind of draw them in a straight line. And then my bonding pairs. That's 2, 4 electrons. So I have 12 left. I'll just start distributing them. 2, 4, 6, 8, 10, 12. It's best to kind of start around the outside and work your way in. It'll make this next step easier. So now that I've distributed all my 12, I need to make sure that everyone who needs 8 has 8. Well, this oxygen has 2, 4, 6, 8. That one's good. This oxygen has 2, 4, 6, 8. That one's good. But the carbon only has 2, 4 electrons. It needs to have more sharing. So I'm going to take 2 from that oxygen, 2 from that oxygen, and share more. I have oxygen double bonded now to carbon, so 2 shared pairs of electrons with each oxygen, and then each oxygen still has 2 unbonded pairs to go along with it. If you count them up around the carbon, you have 8 valence electrons now, 2, 4, 6, 8, and then 2, 4, 6, 8 around each oxygen. Let's just do one more so we can see what that idea of a triple bond looks like. So total up my valence electrons again. Carbon has 4. Oxygen has 6. That's 10 total valence electrons. Arrange my atoms. I only have 2, so side by side. Put in a bond. Single bond, 2 electrons, 8 left. 2, 4, 6, 8. Oxygen is good. It has 8 around it, but this carbon only has 4. It needs 2 more pairs of electrons. So oxygen needs to share 1, 2 pairs of electrons. So it's carbon triple bonded, 3 shared pairs of electrons to oxygen, and each of them have 1 set of unpaired electrons. 2, 4, 6, 8, 2, 4, 6, 8. They are sharing a total of 6 electrons. It's important to note that these Lewis dot structures tell you something about the compound's physical properties. Okay? Those properties that we're mainly going to talk about are melting point and boiling point. Melting is the process by which particles of a substance begin to move quickly and further apart, and the same thing, boiling, but even more quickly and even more further apart. So how closely tied together, or the forces that are holding these molecules together, plays a part in the melting point. Higher forces means higher melting point and higher boiling point. And it comes down to this idea of polarity. We're just going to take down the definitions right now, and then we're going to work with it in class tomorrow. So we have polar molecules and nonpolar molecules. Polar molecules have lone pairs of electrons on the central atom in the Lewis dot structure. Or, notice the or there, so it's one or the other. Both of these don't have to be true for it to be polar. They have one terminal atom that differs from the other terminal atom, so there's some sort of asymmetry. Non-polar molecules are neither of these. They have no lone pair electrons on the, careful there, key there is central atom, and all terminal atoms are similar, so they're symmetrical. There's no asymmetry going on. We are going to apply this in class tomorrow, and then also extend it to 3-dimensional shapes. I just need you to have these definitions for polar and nonpolar molecules down.